Hello students, welcome to my YouTube channel. And in previous video I explained the concept and some examples related to exercise 3.2, and I hope that all of you have understood whatever I explained in the previous video. Because if you don't understand, if you have not understood the concept and the examples and theorems related to exercise 3.2, it will be difficult for you to understand the sums of exercise 3.2. So even if you have not understood, please repeat the video, then you may understand properly. Now we are going to start exercise 3.2. Number 1, show that the square of an odd integer is expressible in the form 3k or 3k plus 1. We have to express either 3k, means both 3k and 3k plus 1. So as I have already explained, A is equal to BQ plus R, and this one, these two conditions you have to remember always for exercise 3.2. And of course Q is always integers, that you have to remember always for all the sums of exercise 3.2. So that square of an odd integer is expressible in the form of 3k or 3k plus 1. So we will take directly, let A and B be two integers. A and B be two integers. Or after that we can write and let's consider B is equal to 3, because 3k is there. B we are taking as 3. So therefore these two we will have to write again. This is the general form for division algorithm. So since we have taken B equals to 3, so we will write now A is equal to 3Q plus R. B is 3, so BQ will be 3Q. Now this is the place for B. B is 3. So that means what? R is equal to 0, 1, 2. R is smaller than 3. So you can write till 2. This is what I explained already in previous video. Please go through. And now there is the square of an odd integer. So for R is equal to 0. That means in place of R we will put 0 now. So let us write A is equal to 3Q plus 0. R is 0. So A is equal to 3Q. This is not enough. This is not finished, because there is even square. We are thinking that A is an odd number. A and B be two integers. So we are thinking, because odd number, so A is odd number. This A we will have to express in 3k or 3k plus 1. 3k or 3k plus 1. Now what we will do? We will do squaring method. Very simple. Sorry, squaring. Why are you doing squaring? Because in the question square of an, so that is why squaring is done. So A square is equal to 9Q square. A square is equal to 9Q square. So I am writing here A square is equal to, there is 3k. So we will make it 3k. 3 into 3Q square. 9Q square, we can add 3 into 3Q square, because our aim is to make 3K What is k? Where k is equal to 3q square, which belongs to z. Q is z. Any q is multiplied with any number, divided by any number, addition with any number, so you will get an integer. So if anything exists q, if anywhere q is existed, q is present, so that will be belong to integers. So a square is equal to 3k, one we have proved already. So this one we can write a sentence here. Therefore there is nothing to write. A square equals 3k. So 1 we have done 3k. Next we will go to, we have done r equals to 0. But r equals to 1 and 2 also we have to do. Let us see what do we get. For r equals to 1. Now we will write this one again. A equals to 3q plus r. Now we will write a is equal to 3q plus 1 because r is 1. Implies a square is equal to 3q plus 1 whole square. Squaring both sides is done because in the question square is there. That is why we are doing square. So you may have the question why squaring is done. Because in the question square is done. Square is mentioned. So we have to do squaring both sides. So a square is equal to 3, this one a square plus 2ab plus b square. Now a square is equal to 9q square plus 6q plus 1. A square is equal to, now since this is one term, so we have tried for 3k. One term only, 9q square, one term, there is no plus minus nothing. So one term we have made this 3k because it is required. But here it is not one term. The 2-3 terms are there, so we will try to get k plus 1. So 3k plus 1. 3k plus 1. Of course we have got plus 1 already. 3k plus 1, already we have got plus 1. So we will try to get from here 3k. 3. Remember that the number is 3. So that is why we will take 3 common. From these two, we will take 3 common. 3q square plus 2q plus 1. So there may be a question, why 3 is taken common? Why q is not taken common? Q also could have been taken common, but no use. We need 3k plus 1. We have to follow this one, what is written here, 3k plus 1. So we will write now a square is equal to 3k plus 1, where k is equal to 3q square plus 2q, which belong to z. So 3k plus 1 we have got. 3k plus 1 we have got. Now one more is there to do. So I think here we will not have the space to do. So we will go to next page. Now r equals to 0, r equals to 0 already we have done, which was expressed as 3k. R equals to 1 we have done already, which is expressed as 3k plus 1 because that is needed. So already we have actually finished the answer. The sum is actually finished, but one more left. R equals to 0, 1 we have done, but r equals to 2 is not done, so we let us do r equals to 2 also. For r equals to 2, for r equals to 2, a equals to 3q plus 2, r is 2. So squaring both sides here also, process is same. Only everything will be dependent on the calculation. Once you mistake any calculation, any part of the calculation, so whole sum will be wrong. A square is equal to a plus b whole square. A square plus a b plus b square. A square is equal to 9q square plus 2 to the 6 to the 12q plus 4. Now, what we are supposed to get? 3k plus 1. I hope this. Yes, 3k plus 1. We are supposed to get 3k plus 1. So, anyhow, we need 3 and 1. So, here 1 is missing. So, let us make first 1. After that, we will think of others. 3 plus 1. Because 3k plus 1 we need. So, we have made it 4 as 3 plus 1. Now, let us see from here 3 commons. There will be 3 common or not. Whether there is 3 common or not. Whether we can take 3 common or not. Why 3 common? Because 3k plus 1. A square, just we will take 3 common, nothing else. 3q square 4q plus 1 plus 1. 3 is taken common. Now directly, here you don't have to think much here. 3 then k plus 1. Very easy sum. Where k in place of whatever you have written k, just same value you have to put here. So this is not complicated. Belongs to Z. This whole terms belongs to Z. Why? Because Q is present. So this number 1 is finished. Number 2. Show that the cube of an integer can be expressed in the form 9k plus 1, 9k plus 1 or 9k plus 8. 9k. So, like previous sum, in the previous sum there was, what was there? 3k plus 1. Here 9k plus 1. So, still we will take 3 only. For B, we will take 3. That will be easy for us. If we take a bigger number, that may be very difficult for us to do calculation. Because 9 and 3 both are multiples of 3. So, better we take 3 so that we can do something. So, here also let A and B be 2 integers. This you have to write, remember that. And let's assume B is equal to 3. Now we will start the sum. What we will start? Let me write here. A equals to BQ plus R. This is what every time please note down whenever you do any sum of exercise 3.2. I hope this is 3.2, no? Yes, 3.2. Now, in place of B, we will write 3 now. A is equal to 3Q plus R. BQ plus R, 3Q plus R. Now, 3. This is the place for B. So, R is equal to 0, 1, 2. That is very simple. So, for R is equal to 0, we will do the sum. A is equal to 3Q plus 0. R is 0. Now A is equal to 3Q. Now we will do squaring both sides or cubing both sides. That depends on the question. That will be according to the question. In the question, if it is written square, we will do squaring both sides. If it is written cube, we will do cubing both sides. So let us do cubing both sides. Cube is written there. So A cube is equal to 3Q whole cube. Cubing both sides. So A cube is equal to 27Q cube. This can be written here as A cube is equal to what we need? 9K. We need 9K. This is single term. So we will go for 9K. We will not go to 9K plus 1. So what? 9 into 3Q cube. 3Q cube. 9 3 is 27. Now we will write A cube is equal to 9K. Where K is equal to 3Q cube belongs to Z. Hope all of you have understood that. Very simple sum. Don't make it complicated. And don't think that this is complicated. This is hard sum. What is done? You just tell me. Just to remember this one. A equals to BQ plus R. And R is greater than equal to 0 and smaller than B. That much only you have to remember. After the whole thing is according to the question. When the question cube is written, so cube is done. Whatever is told, we just to follow. And everything is here nothing to remember. Here nothing to learn by heart. So don't think that it is a hard sum. The name of the lesson may be hard, algorithm, division algorithm. Maybe words may be very difficult to say. You may think that words are very difficult, but it is not difficult. Okay. So we have got this one already finished. 9k we have got. We will go to 9k plus 1, but before that what we have done? R equals to 0 we have done. Now we will go to R equals to 1. So for R equals to 1, A is equal to 3Q plus 1. Now we will do just simply cubing both sides. Cubing both sides. So I am not going to explain again why cubing both sides is done, because already I explained. So A cube, this is A plus B whole cube. A cube plus 3A square B plus 3AB square plus B cube. Just A plus B whole cube formula is applied. A cube plus, equals to 27Q cube plus 3 square is 9, which is a 27 only. 27Q square plus 9Q plus 1 plus 1. So A cube, what is our aim? 9k plus 1. So from here we will try to get 9 common. Plus 1 is already we have with us. So surely we will get 9 common here. But 27, 27, 9. So all are divisible by 9. So 9 can be taken common. So directly we can write A cube is equal to 9k plus 1. Plus 1 plus 1 only. Where k is equal to 3q cube plus 3q square plus q belongs to Z. Now let me tell you one thing again. Here not only 9, we also can take q also common. Because in each term q is present. But we are not going to take q common, because we have to follow the question. 9k. So for k we need a term inside the bracket. That is why q is not taken common. Even if we have taken common, that also no problem. But better we do this way, so that directly we can that belongs to Z. So R equals to 1, 9k plus 1 we have got. Now R equals to 2 is left. We will do R equals to 2. For R equals to 2, A is equal to 3Q plus 2. So here also we will do cubing both sides. A cube, A plus B whole cube. A cube plus 3A square B plus 3AB square plus B cube. So A cube is equal to 27Q cube. 3 9 are 27 into 2, 54 Q square. 3 3 are 9, 9 to the 36, 36 Q plus 8. What is our aim to get? 9k plus 8. Okay, 9k plus 8. We have got 9k already. we have got 9k plus 1 here. So what is left? 9k plus 8. Let us see from here we get 9k plus 8 or not. Whether it is possible to get 9k plus 8 or not. By looking this term, at least we understand plus 8 is there. Plus 8 is there. I hope you understand. So from here, what is our aim to get common? 9. We are supposed to get 9 common. So we are sure that we will get 9 common because all are divisible by 9. 3q cube 6q square plus 4q plus 8. Sum is very easy. According to question, you will have to take the common. If it is there 12, we could have taken 12 common. If there is 3k plus 8, then we could have taken 3 common. So now a cube 9k plus 8 plus 8. So in place of this k is written where k is equal to 3q cube plus 6q square plus 4k belong to z. So we have got 9k plus 8 also. That is finished. Number 3. Number 3, huh? Number 3, for any n belongs to natural number. What is n? Small letter of n is here. Prove that n into n plus 1 into 2n plus 1 by 6 is an integer. So here also we will take 2 integers left. Let a and b be 2 integers. And let us assume b is equal to 6 because 6 is here, so we can get cancelled. Where we have the possibility to get cancelled 6, that is why b is taking 6. So let me write again this one, pq plus r. This one you have to write again and again, then only you can remember. So now a equals to bq plus r. Now we will write a is equal to 6q plus r. So 0 r 6, b is 6. So what is r then? R is equal to 0, 1, 2, 3, 4, 5. R is smaller than 6. So we will write till 5. So let us do one by one now. For r is equal to 0, let us do for 0 now. If r is equal to 0, then a is equal to 6q. 6q plus 0, we are not going to write again and again. A is equal to 6q. So something I have done mistaken here. Actually, I could have taken here in the previous sums. In the previous sums, there is no expression given. So that is why we have taken a and b directly. But here we will take n and b. Okay, you can take this way also. Let us assume, you can write this way also. A is equal to n and b is equal to 6. This way we can write. Now, what I have told, a equals to n. Why taken n? Because a is not there, n is there. Expression is given in which n is present. So, in place of a, we will write n and b is 6. A equals to bq plus r. So, n equals to 6q plus r. Why n is taken? I have already explained. Because the term is the expression is in term of n. So, that is why n is taken in place of a. Now, r equals to, so a will be n. If r equals to 0, n equals to 6q. 6q plus 0, we don't write, that is needed, that is known to us. So now in the expression n into n plus 1 into 2n plus 1 by 6, we will put the value of n, what? 6q. N is how much? 6q. 6q into n plus 1, 6q plus 1, 2n plus 1, 2 into 6q plus 1. Just simply to put the value of n as 6q. After that, just calculation only. Let us write here 6q into 6q plus 1 into 12q plus 1 by 6. At least 6 we can get cancelled, that you know, because multiplication is there. So now what is to prove? That by putting r equals to 0, whatever result we will get from here, that is also integer, is an integer. That means whatever term we get, in every term there must be q present. Q must be present. So as I already told you, what for any integer, q must be shown here, q, because q is always integer. So here it is finished actually, the sum is already finished. Belongs to z, because q is, since q is an integer. Q is integer, so multiplication of q with any number, addition of q with any number will be also integer. So we have proved by putting r equals to 0, this expression is an integer. Just now we have proved. Now we will go to r equals to 1. For r equals to 1, 6, n equals to 6q plus r, n equals to 6q plus 1, because r equals to 1. Now in this term we will put the value of m. This one little big calculation, no problem, just calculation is big but easy. So n into n plus 1 into 2n plus 1 by 6, just to do the calculation correctly. In place of n, we have to put 6q plus 1. Instead of n, 6q plus 1. So 6q plus 1. This n is finished. Now n plus 1. 6q plus 1 plus 1. 2, 6q plus 1 plus 1. I hope you understand. Okay. Let us do the calculation. Let us see what we get. 6q plus 1. Here 6q plus 2. Here 12q. 2 1 the 2. 2 plus 1. 3. Let us write correctly. No need to do so big calculation. So equal sign here. 6. 6q plus 1, we cannot take anything common from these two terms. But from these two terms, we can take 2 common. 2, 3q plus 1. I hope you understand. Then 12q plus 3. From here, we can take 3 common. 4q plus 1. 2, 3 is 6 and 6 cancel. So, whatever you get, that belongs to z. Here, there is nothing to think. Don't make it complicated. Q present means integer. Belongs to z. Everywhere q is present, so belongs to z. Now, so it will be, you can write similarly. Similarly, we can do, we don't need to do all the 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 times we have to do calculation. So let us do one more. After that we can do similarly. R equals to 1 finished. Now we will do R equals to 2. After that we will write similarly we can have. For R equals to 2. For r equals to 2, what we get? N equals to 6q plus 2, I hope. N equals to 6q plus 2. Okay. Now, n into n plus 1 into 2n plus 1 into 2n plus 1 by 6. N will be now 6q plus 2. In place of n, 6q plus 2. Again 6q plus 2 plus 1. 2 into 6q plus 2 plus 1 divided by 6. Just to do the calculation. 6q plus 2. Here 6q plus 3. Here 2 6 are 12q plus 2 to the 4, 4 plus 1, 5. 2 6 are 12. 2n plus 1. Okay. It is 5. Okay, no problem. 6. Here we can take 2 common. 3q plus 1. Here we can take 3 common. 2q plus 1. 12q plus 5. Let it be as it is. 2, 3 is 6. 6 cancel. Equals to what we have got? 3q plus 1. Then 2q plus 1. And 12q plus 5 belongs to Z. So similarly we can have should not be together. We can have n into n plus 1 into 2n plus 1 by 6 will be an integer by putting the value of n equals to, sorry, r equals to, we have done 0, 1, 2. R equals to, by putting r equals to 0, r equals to 1 and r equals to 2, we have done the calculation. So 3, 4, 5. I think 5 is also there. 3, 4, 5. 3, 4, 5. Similarly, we can have this one will be an integer by putting the value of r as 3, 4, 5. That's all. Number 4. Number 4, for any n belongs to n, that means n into 7 n square plus 5 is expressible in the form of 6k. So, like previous sum, there was an expression given in which n was there, small letter of n. So, in place of a, we have taken m. So, here also n is here. So, we will take a as n. A equals to bq plus r. So, here a in place of a, we will write n. So, let this you know now. I am not going to write again and again. A and b be two integers. Assuming a equals to n and b equals to 6 because 6k. 7, 6. So, let us take 6 only because 7 will be difficult for us. So, let us see whether we get or not. Once you do the sum, then you will understand. Okay. Now, we will write the expression a equals to bq plus r. We will write n equals to 6q plus r. bq will be 6q because b equals to 6. Now, we have to write this. R equals to 0, 1, 2, 3, 4, 5. R is smaller than 6. 1, 2, 3, 4, 5, 6 times we have to do. Like previous sum, we will do later part similarly. Okay, let us put now r equals to, for r equals to 0, n equals to 6q. r is 0, so n equals to 6q will be left. This is the main term. Remember that. For r equals to 1, you will put the value here 1. R equals to 2, you will put the value of R2 here in this term. So this way it will go on. So what is the term given? N equals to 7n square plus 5. So in place of n, we will get 6q. 6q plus into 7 into 6q square plus 5. This should be second bracket. 6q. 7 into 36 q square plus 5. 6q, 7 6 are 42, 7 3 are 21 for 25, q square plus 5. I hope it is correct. Yes. Okay, what we have to get? 6k. We have to get 6k. So 6 is already there. So this whole term we can think as k. Do you understand that? I hope you understand. What is our aim to get? 6k. 6 is already there. So rest of the terms we can take as k. No problem for us. Or you can do one more term. This one we can just make it like the 6 bracket 252 q cube. Let us multiply 5q. Now also you can write 6k. No problem for us. This is k. Where? This you must write. Remember that. Belongs to Z. This one you have to write. Let us see calculation is correct or not. Yes. Calculation is correct. Now, by putting r equals to 0, we have finished the work. Now r equals to 1. Or r equals to 1. This one. N equals to 6q plus 1. Now n equals to 6q plus 1. Now this one we will add again. The term which is given in the question we will add again for r equals to 1. N into 7n square plus 5. Just to do the calculation, nothing else. In place of n, 6q plus 1. 7, 6q plus 1 whole square plus 5. 6q plus 1. 7, this one 36 q square, a plus b whole square formula directly we can do. 2 6 are 12, 12q plus 1 plus 5. Simple calculation. 6q plus 1. 7 into 36, 252 cube. 252 q square plus 87, 12 to 84 q plus 7 plus 5. Okay. Now 6q plus 1. Okay, let us write one more time. 252q square plus 84q plus 12. What is our aim? We have to get 6k. We are supposed to get 6k. 6 into something. 6 into something. Something means in that something q must be present. Q must be present. Okay. 6q plus 1. 6 I have written here because from here we can get 6 common. But each term is divisible by 6. Whether you write 6 or here, because multiplication, no, so you can add in any place. Position doesn't matter in multiplication. So 6 into how much is 42. 6 into 42 is 252. 6 into 14 is 84. 6 2 are 12. 6 into this one is this one. 6 into this is this. 6 into 2 is this. So we have got 6 into something. So we can write k directly. Where 6q plus 1 into 42q square plus 14q plus 2 belongs to Z. Very simple. We have done the sum for r equals to 1. Now we will do once for r equals to 2 also. For r equals to 2, what is there? N equals to 6q plus 2. N equals to 6q plus r. R is 2 now. Sorry. R is 2. R is 2. Now the term is there. What is the term? 7n into 7n square plus 5. N into 7n square plus 5. Just to put the value, 6q plus 2. 7 into 6q plus 2 whole square plus 5. 6q plus 2. 7 into 36q square. 2 to the 4, 4 6 are 24. 24q plus 2 square is 4 plus 5. Okay. 6q plus 2. Now 7 into 36. Okay. 7 into 36, 7 6 is 42 or 252 q square. 7 into 24, 7 4 is 28. 7 2 is 14 plus 2, 16. 7 4 is 28 plus 5. 6q plus 2, 252 q square plus 168q plus 33. Seven n square plus 5 n square. Okay, no problem. So from these two terms we can have 2 common. No, 2 3q plus 1. From these we can take 3 common. 3 8 is 24, 3 4 is 12, 3 5 is 15, 3 6 is 18, 3 11 is 33. So we have got 6. We have got 6 into 3q plus 1, 84q square plus 56q plus 11. So we can write directly now 6k, where 3q plus 1, 84q square plus 56q plus 11 belongs to Z. Now similarly by putting r equals to 3 4 5 n into 7n square plus 5 is an integer. Oh sorry, not integer, can be expressed as 6k. This is what you have to write. We don't have to do again and again, so it will be a big term, big sums, so we don't have to do again and again. Number 5. If n is an odd integer, show that n to the power 4 plus 4n square plus 11 is expressible in the form of 16k. We have to express the term as 16k. Okay. A equals to BQ plus R. This one, let me write again and again, no problem for us. Here since n is there, so we will take A as n. So I am not going to write left this part, you will write yourself. So I will going to write directly n equals to, here B is taking as 4, because 16 is divisible by 4, so it will be easy for us to take 4. 4 for the 16. So n equals to, B is equal to 4. So BQ, so 4Q plus R. 0 R 4. Sorry, it is 4. That means r equals to 0, 1, 2, 3, 1, 2, 3, 4 times. We will have to do 4 times calculation. Now, since it is an odd integer, so 4q is there. With 4q, if we add 0, this will be even. If with 4q you add 1, this will be an odd number. N will be odd. When n will be odd? When r is something odd, because this term is already multiplied with 4, so this will be even always. But in r, if you put 1 and 3, in place of r, if you put 1 and 3, then only you will get odd, because n should be odd. So we will do for r equals to 1 and r equals to 3 only. I hope you understand what I want to say. See, n equals to 4q plus r. Here is written n is odd integer. N is odd integer. So when will be an odd integer? When this place is odd. Suppose 4 into anything is 4 only. 4 into 1 is 4, 4 to the 8. In place of q, whatever number you write, this term will be always even. But n is odd number. So with this even, if you add 0, that will be even only. With this even number, if you add 2, that will be also even. So instead of adding 2, 4, 6, any even number, we have to add here odd number. So even number plus 1, even number plus 3, so we will get an odd. So you will put the value of r 1 and 3 only. 0 and 2 we will not use. I hope you are clear about what I explained. Because clearly in the question it is written n is an odd number. So for n equals to 0, we are not going to write. Sorry, r equals to 0, we are not going to write. We will write directly r equals to 1. Then n equals to 4q plus 1, which is odd. Now n to the power 4 plus 4n square plus 11. In this term, n will be 4q plus 1. 4q plus 1 whole to the power 4 plus 4q plus 1 whole square 11. So now power 4, there is no formula. So we have to make it square. Hope you understand. This one we will do now. Q square. So this calculation I am going to do directly. So I have done the calculation already, because here doing the calculation it will take much time. And this squaring is done. 16q square plus 8q plus 1 whole square. Again okay, again 4 into 16q square plus 8q plus 1, then plus 11. So this one again you have to do a plus b plus c whole square formula. What is a plus b plus c whole square formula? A square plus b square plus c square plus 2ab, 2bc, 2ca. This is the formula you have to apply. A plus b plus c whole square formula. So I am not going to write, you will write yourself. This one like this, 16q square plus 8q whole square plus 1 square. So it will be like this. So after the calculation will be there. At last 256 q to the power 4 plus 256 q cube plus 160 q square plus 48 48 cube plus 16. Plus 16. So here we can take 16 common. From all these terms we can take 16 common. Because why we are going to take 16 common? Because in the question 16k is there. So 16 16 ja 256. 16 60 ja 256. 16 1 ja 16. 16 3 ja 48. 16 1 ja 1. So this is k equals to 16k. Where 16k square k to the power 4, okay, 4 16k cube plus q square plus 3k plus 1 belongs to z. So this is the calculation done by putting r equals to 1. Next we will have to put r equals to 3. We have done here r equals to 1 and we have to do r equals to 3 also. So for r equals to 3, n equals to 4q plus 3. N equals to 4q plus 3. So what is the term? N to the power 4. N to the power 4 plus 4 n square plus 11. So 4q plus 3 whole to the power 4. 4q plus 3 whole square plus 11. So now what you have to do? 4q plus 3 whole square, again square, 4q plus 3 whole square plus 11. So this calculation I will do, I have done already, so I will do here. I am not going to waste the time. Okay, one line you can write 4q whole square 2 into 4q into 3 plus 3 square, again whole square, 4 into 4q whole square 2 into 4q into 3 plus 3 square plus 11. 16q square, 2 4 ja 8, 8 ja 24q plus 9 whole square, 4, same thing, 16q square plus 24q plus 9 plus 11. Now what we will have to do? A plus b plus c whole square. A square plus b square plus c square. 2a b plus 2b c plus 2c a square plus b square plus c square plus 2ab plus 2bc plus 2ca, a plus b plus c whole square. 4 into 16, this one 64 q square, 4 into 24 96 q, 4 into 9 36 plus 11. So this calculation is at last got. I am writing directly. Okay, 256 q to the power 4. This one 24 square is 576 q square. 576 q square plus, this is 9, I think, not q. This is 9, not q. There is 9. 9 square is 81 plus 2 into 16 q is 768 q cube. 768 q cube. This one, this calculation. Q square into q is q cube. Then 432 cube. 432 cube plus this one 432 cube. This one 288 q square. 288 q square plus this one is as it is 64 q square plus 96 q plus 36 plus 11. So after doing all the calculation, square all addition, cube all addition, 256 q to the power 4 plus 768 q cube plus 928 q square plus 528 q plus 128. 81, 36, 11, 128. So this one can be divisible by 16 because our aim is to get 16k. 16k can common. After taking 16 common, 16 that 256 that we know. 16 into 48 is 768. 16 into 40, 768. If we divide by 16, 768 if we divide by 16, 4 16 the 64, 2 8 48. Then 928 if we divide by 16, 6 16 the 96, oh sorry, 5 16 the 80, 128, 58. 58 q square plus 33 q plus 8. So 16k. This is k, where k is equal to whole term you can write. After that, similarly, you don't have to do all, sorry, it is finished only because we have to do all 1 and 3 only. For 1 and 3 only we have done. For 1 we have done this calculation. For 3 also we have done this calculation where we have got 16k. Number 6. Show that an integer and its cube give the same remainder when divided by 6. Now meaning of the question. Meaning of the question first you have to understand, then only you can do the sum. So that the integer and its cube give the same remainder when divided by 6. It is like this. One remainder, when number is suppose 12. 12, okay. 12. So that an integer and its cube give the same remainder. So this 6, if by 6 if we divide 6 to the 12, so remainder is 0. Now its cube, 12 cube, 144 into 12, 288, 144, 1628. If we divide by 6, so that an integer and its cube give the same remainder when divided by 6. An integer and its cube. 12 its cube. 2 for the 8, 2 for the 8, 1 for the 2, 1 for the 4, 1 for the 4. So it should be 1728. It should be 1728, okay. 1728 if we divide by 6, 6 2 is 12, 52, 6 is 48, 6 is 48, 0. Number is 12 and another one is 1728. It's 12 cube. 12 cube is 1728. The integer is 12 and its cube is 1728. If you divide, 12 if you divide by 6, getting remainder 0. 1728 if you divide by 6, then also getting remainder 0. That is what the question. So that an integer and its cube give the same remainder when divided by 0. We have got same remainder, that is 0. So this is the example I have shown you. You can pause the video, you can note it down So now we will take two numbers A and B we will take 6 because it is divisible by 6. So I am not going to write let and all these things. You will write yourself because you know what to write. As the term is A equals to BQ plus R 0 R B. The B is 6. So A is equal to 6Q plus R 0 R 6. R equals to 0 1 2 3 4 5. So big calculation. For R equals to 0, then we will put the value, then we will do cubing both sides. R equal to 2, R equal to 1, then we will not do all. We will see that 6 something. The term with whatever number with that, if 6 is present, that means that will be divisible by 6. That we can understand at least. So A equals to 6Q. First we will put R equals to 0. For R equals to 0, A is equal to 6Q. 6Q plus R is 0. So let us do this one here. Cubing both sides. Why cubing both sides? Because here cube is given. A cube is equal to 216Q cube. Or we can write A cube is equal to 6 into 36Q cube. Or A cube is equal to 6K, where K is equal to 36K cube belongs to Z. This 6K is divisible by 0 or not? Okay, little mistake. Okay, wait. Don't mind please, there is something little mistake. Okay, when R equals to 0, then you can add A equals to 6Q plus 0. What is the integer? Integer is A. If we divide A by 6, what is the remainder? In place of R, what is there? 0. So here, remainder is 0. A equals to BQ plus R. B means outside, A means inside, Q is here, R is here. That you know already, I explained it. This is division, quotient, and R, remainder. So BQ plus R, whatever number is there in this place, that is remainder. A equals to 6Q plus 0. So A is, we have taken now, let A be an integer. So that an integer and its cube give the same remainder. A is an integer, its remainder is 0. Now if we do cubing, then also 0 or not we see. 6Q plus 0 is 6Q only. A cube is equal to 216Q cube plus 0 we can write here. Plus 0 not the same thing. A cube is equal to 6 into 36Q cube plus 0. 6Q plus R. What is R? Remainder, 0. So here also remainder is 0. In A, remainder is 0. In A cube also, remainder is 0. That is what we have proved. That is what we are supposed to prove. So that an integer and its cube is given same remainder when divided by 6. How can we understand that is divided by 6? Because in place of B, 6 is there. In place of B, 6 is there. In place of B, 6 is there means by 6 we are dividing something. Now by putting R equals to 1. For R equals to 1, A is equal to 6Q plus 1. In place of R we have put 1. That means here remainder is 1. Now cubing we will do. Let us see. By cubing also we get remainder 1 or not. Without cubing, remainder is 1. After cubing, remainder also we must suppose to get 1. So a cube is equal to 6 cube plus 1 whole cube. A cube plus, equal sign, 6 cube whole cube 3 a square b plus 3a b square plus b cube. A cube is equal to 216 q cube plus 3 into 36 108 q square 3 6 18 3a square b 3a b square, something is 3a square b 3a b square, there is something wrong here, 3a b square. So 18q plus 1, what we have to get? Remainder 1. So a cube is equal to 6 something plus 1 we need. A equals to 6q plus 1. 6 something, something is k. Okay, 6 we will take common now. 36q cube 1 18q square plus 3q plus 1. We can write now a cube is equal to 6k plus 1, where k is equal to 36k q cube 18k square plus 3q belongs to z. Therefore, here also remainder is 1. Here remainder is 1. Here also remainder is 1. With a we have got remainder 1. With a cube also we have got remainder 1. So that an integer and its cube give the same remainder. I hope you understand. Now r equals to 2. For r equals to 2, a equals to 6q plus 2, I think. A equals to 6q plus 2. So a equals to 6q plus 2. Remainder is equal to 2 because in place of r2 is there without cubing. We will do cubing now. We will do cubing. A cube is equal to 6q plus 2 whole cube. A cube 36q whole cube 3a square b plus 3a b square b cube. A cube is equal to 216q cube plus 3 to the 6 into 36. R equals to 2. Let me see the calculation. We don't have to do again. Okay, this is same. 216q square, then 72q plus 8. A cube is equal to what is our aim? At last plus 2 is required. 216q cube 216q square 72q plus 6 plus 2. This is important part. Here in a remainder we have got 2. In a cube also we have to get remainder 2 because that is why we are putting plus 2 separately. A is written 6 plus 2. Now we will try to get 6. 6 we will take common. 36 q square q cube 36 q square 6 12 the q 6 1 the 6 plus 2. So a cube is equal to 6k plus 2, where k is equal to 36k cube 36k q square plus 12q plus 1 belongs to z. Here also remainder remainder is equal to 2. I hope you understand. Like 3, 4, we can go on doing. You can do yourself this one. Just calculation must be done properly. Number 7. Number 7. I think number 7 is the last sum. Yes. Show that the difference of a number and its sequence is always an even number. So even number, so you will take A and B equals to 2. Even number, no? Show that the difference of a number and its square is always an even number. So this is like this. One number is 4 and its square is 4 square. One even number is 4 and its square is 4 square. The difference is always even. 4 square is 16 minus 4 is 12, always even. 4 square. A number and its square. The number I have written here, square I have written here because we have to subtract, so bigger number should be written first. Okay, I hope you understand that. That is here also written A square minus A. This is hint given, hint. A square minus A is an even integer. Okay. So A is equal to BQ plus R and 0 R P. B we have taken 2. A is equal to 2Q plus R. So R is equal to 0 and 1 only. Because R is smaller than 2 till 1. So R is equal to 0. Then for R is equal to 0, A is equal to 2Q only. A is equal to 2Q. What? A square minus A. We have got the value of A. Now we are going to get the value of A square. So A square is equal to 2Q square. A square is equal to 4Q square. Let us see now A square minus A is even integer or not. Let us see. A square minus A. What is A square? 4Q square. 4Q square. What is A? 2Q. 2 can be taken common. 2Q square minus Q. 2K, where K is equal to 2K square minus Q belongs to Z. 2K is always even. So A square minus A is even. Therefore, A square minus A is even. When R equals to 0. Now we will do R equals to 1. For R equals to 1, then A is equal to 2Q plus 1. 2Q plus 1. Now we will do squaring. A square 2Q plus 1 whole square. A square 2Q, A square plus B 2AB plus B square. So A square 4Q square plus 4Q plus 1. Now we will have to see A square minus A, whether it is even or not. Now A square minus A square, this is the value 4Q square plus 4Q plus 1 minus A, this is A, 2Q plus 1. I have put bracket because of this minus sign, as you know that. 4Q square plus 4Q plus 1 minus 2Q minus 1. Plus 1 minus 1 cancel. So 4Q square plus 4Q minus 2Q is plus 2Q. So we will take 2 common here also. So 2K. 2 into something means even integer. So where K is equal to 2K square plus Q belongs to Z. Therefore, A square minus A is even 2K. We have got 2 into something. So I hope you all understand. All of you have understood all the sums of exercise 3.2. I tried my best to make you understand the sums. Still, I am expecting to get some feedback. I am expecting to get some comments from you, whether you have been understanding clearly all the sums, whatever I explain in different videos. Then only I may get encouraged, I may get to do all the works with proper energy. So that is why I tell you seriously to get some comments that whether you are able to understand my explanation or not. Okay, till then, good day, and next I will explain the examples and concepts for exercise 3.3. Thank you.